Hi, my name is Sebastian Matteau, and today I want to give you a quick demonstration of DataMatrix. Now, DataMatrix is a Python library for working with column-based data. So column-based data is the kind of data of the format that you see here. I'll scroll down. So this is on the first row we have our column names, name, field, and gender in this case. And then on the rows below, we have the actual data, right? So if I talk about column-based data or tabular data, that's the kind of data that I mean. That consists of columns and rows. In that sense, DataMatrix is similar to, for example, Python libraries such as Pandas or even NumPy, which can do much more. They are much more elaborate than DataMatrix. But what DataMatrix can do very well and better than other libraries, I think, is make working with data intuitive and very readable. So I've put a lot of work into developing a very intuitive and Pythonic syntax for working with tabular column-based data. Now, the first thing that you need to do, of course, is install DataMatrix. So let's take a look. DataMatrix has no dependencies other than Python, right? So it runs with only the Python standard library. So the only thing that you really need to do is say pip install Python -DataMatrix. But you may also want to install a few dependencies just to make things faster and to allow DataMatrix to print out stuff to the terminal. To do that, you can say pip install fastnumbers, which is a library that speeds things up a little bit in the background. NumPy and SciPy, right, the standard Python libraries for working with numeric data. PrettyTable, a library for making nicely formatted tables. And OpenPixel, a library for working with Excel data files. Right, but the only thing you really need to do is pip install Python DataMatrix. Now, what are we going to do today? We're going to play with movie data using DataMatrix, of course. And we're going to use a very nice data set that I downloaded from here. That contains, I'll just show you the data. That contains titles of a whole bunch of movies, the years in which the movies appeared, and then ratings, which are I believe the average ratings given by experts on Rotten Tomato or something like that. Now, so we have 3 columns, right? And a whole bunch of rows. We have in total, more than, let's scroll down, more than 10,000 movies. Now, let's go back. So we're going to use, you can use DataMatrix in any kind of Python terminal. Here I'm going to use IPython, an IPython notebook, right? A Python terminal embedded in a website. And the first thing that we're going to need to do is import DataMatrix. So I'll just import all the libraries that we're going to use. Import DataMatrix from DataMatrix, import IO. IO is a module that allows DataMatrix to read and write Excel files and comma-separated values files, right? CSV files. And we need another module, operations. And because operations is a bit long, I'm going to import it as ops. Operations contains a lot of things that you can do with DataMatrix objects, such as sorting them, etc., splitting them into bits, etc. Okay, so let's execute this. Then we're going to read in the data. So I'm going to say dm is io.read xlsx, right? So we're going to read in an Excel spreadsheet. And the spreadsheet is called movies.xlsx. And then I'm going to print it out. Okay, so I'm going to execute it. Takes a little while because it's quite big. There we go. So you see, now we have a nice printed representation of our data matrix with the same data that I just showed you in LibreOffice. It doesn't show you all the rows, right? That would be too big. But there we are. We now have a nice data matrix object. Now, let's say that we're particularly interested in movies from the 70s. Then what we can do is we can make a selection. We can say movies 70s is. And then we're going to use, I think, a very cool feature of DataMatrix, namely its user-friendly way to select rows. So what we can do is dm.year is larger or equal than 1970. And dm.year is smaller or equal to 1979. And then print it out. Again, just to movies 70s. Now, so what's happening here? This very clean syntax, right, allows you to make selections. So you just refer to a column as dot and then column name. dm.year refers to the year column. And then you say, I want to have all rows where this column is larger or equal than 1970, so 1970 or later. And I also want to have those rows where the year is smaller or equal than 1979. And DataMatrix understands that here you want to have a multiple selection, essentially, right? A selection based on two criteria that both need to be true. And you get all the movies from the 70s. So that's, I think, a much more readable and a much more user-friendly way to select data than how data selection works in programs such as, or in libraries such as NumPy or Pandas. Okay, now, then let's say that we want to sort our movies by rating, right? Because we can say, for example, movies 70s is ops, right? It's that library that we, that module that we imported here from DataMatrix import operations as ops. And ops has a sort function that takes the data matrix, and then you have to say what you want to sort it by, and we want to sort it by movies.70s.year. Print it out, movies 70s. And there we go. Wait. Oh, sorry, now I sorted it by year. I actually want to sort it by rating. Oh, there we go. Okay, now you see that actually the rating, we sorted it with the lowest values first, which is actually not what I want to do. I want to sort it with the highest rated movies first. So what we can do is just use the normal Python way to reverse the data matrix, right? Colon, -1 is the Python way to reverse lists or reverse any kind of iterable objects. So if I do that, you see that indeed the order of the list is reversed. You also see that we get a warning that says cannot sort incomparable types, forcing all values to float. And that is because we have, you see that a few movies have as a rating /n, which I guess is missing data or something, right? That's just that it was like that in the data set that I downloaded. So let's throw out all those movies that don't have a rating, right? So let's remove the movies without a rating. Again, we can do that in a very intuitive way. We just say movie 70s is movie 70s dot rating is not a string. And then we print it out. Print movies 70s. And you see that all those funky ratings are now gone. So DataMatrix recognized that here we are comparing this column, the rating column, to a type. And when you compare it to a type, it automatically doesn't check actually the values, right? But it checks whether the values are of that type. So here what we're saying is we want all ratings of which the type is not a string. In other words, all valid ratings, right? Because the invalid ratings, these ones, they were strings. So now we've thrown away all the invalid ratings. So that's pretty easy, right? Now, say that we want to have the mean rating for each year. Then I'm going to demonstrate how you can do that by splitting your data matrix. So what you can do is for year, movies in ops.split. And then we have our movie 70s dot year. And then I can print out in 90 blah blah blah, the mean rating was blah blah blah. And then I say year movies dot rating dot mean. Now if I run that, you will see that it works. And it says in 1970 the mean rating was 5.55, etc, etc. Right, so that's and you see that actually the best year was 1975 with an average of 5.78. So what happens here, this ops.split takes a column and basically it returns an iterator of tuples where the first item of the tuple is the year, or well, is the value of the column that you're splitting it by, so in this case year. And the second element in the tuple is actually a data matrix. In this case, a data matrix of movies, right? Say that we could also, if we want to be a bit more fancy, we could even say, okay, lang movies. And here you would see how many movies there were for every year, right? Because we can take the length of this data matrix that we've split it out of the enormous data matrix, and we print that length here as n is, right? And we see that the most movies were made in 1979, which I guess is not that surprising because more and more movies are being made over time in general. Now, let's say as another exercise. So you see here, the point here was that it's very easy to split your data matrix into based on all kinds of things. Now, to give another example, say that we want to walk through all movies with a title that starts with the. There are quite a few movies of which the title starts with the, right? What we can say is for movie in movies 70s, if movie.title.starts with the, print the name of the movie, movie.title. There will be quite a few probably, right? Look, that's interesting. So we loop through. What happens here, just to explain, is that if we iterate through a data matrix, so movie 70s is the data matrix, then we get row objects. And row objects have properties, and those properties are single values, right? Because each column in each row has only a single value. That's why we can say, for this movie, dot the title, if it starts with the, print out that movie title. Now, and then what we see here is that at some point we get an attribute error. It says int object has no attribute starts with. Why? Well, apparently there is a movie that has a title that is just a number. Maybe it's 1984 or something. So let's make it a bit. If is instance movie.title.str and it starts with this, print out the movie title, right? And now you see we get all, it works, right? That's very nice. We could also print out the whole movie objects, which are rows, and then it would look like this. Right, so movie, the thing that we get when we iterate through a data matrix, is a row object, and when we print out the row object, you get things like this, right? So the title column has the value Godfather Part 2, the year column has the value 1974, and the rating has the value 9.2. Now I'm actually a little bit curious what the movie is that had a numeric title. So if the movie title is not a string, print it out. There are actually a few, right? 1667, 1941, and 21. And not 1948, as I suspected. Okay, so this is how you can iterate through a data matrix getting row objects. Now, say as a final exercise that we want to keep only the 10 best. Is movies 70s up? Okay. We can just do it like this, right? We can slice in our data matrix and then we get the 10 best ones. Chinatown being the best one, being a Roman Polanski kind of dark detective movie with Jack Nicholson. Apparently very good. Never seen it. So now we have essentially already ranked them because we've sorted the data matrix by the rating. But say that we really want to have a rank. Then we can say best10.rank is range 10. And then up, you see that we get a very nice rank. We have an extra column. So when we just assign any kind of value to a non-existing column, in this case rank, the column will be created and it will be filled in one go. what you notice is that we actually start counting at 0. It's maybe not the best idea. So because I would say that the best one is at rank 1, right? Not at rank 0. So let's just add 1. Up. And now we actually start counting at 1, right? So creating columns is very easy in DataMatrix, and assigning values to columns is also very easy. Now, that's essentially what I wanted to show you. This is just a glimpse of the things that you can do with DataMatrix. There is a very nice basic use cheat sheet on the website on datamatrix.coxsci.nl, right? Here, this website. And this cheat sheet allows you to see how you can iterate through DataMatrix objects, how you can select data, how you can perform operations, etc., etc. Okay, now finally let's take a look at which movie was actually the best one. It was this one. Chinatown 1974, Roman Polanski. Had a 9.3 according to Rotten Tomatoes and an 8.2 according to IMDb, which is still not bad. Okay, thank you very much for your attention.